Hi guys, let's take a look at this question where we have a tow truck that pulls a car along a gravel road. The force applied by the engine of the truck is 900 newtons. The mass of the tow truck is 1,300 kgs and the mass of the car is 950 kgs. It's also shown in the diagram. They are connected to each other by an inelastic tow bar of negligible mass, and the tow truck and car is moving at constant velocity. Constant velocity means acceleration is 0. 4.1. Define the term frictional force. So just take this out of your textbook. Frictional force is the force that opposes the motion of an object and which acts parallel to the surface. 4.2. Name and state the law that explains why the force exerted by the tow truck on the car is the same as the force exerted by the car on the tow truck. And that is, of course, Newton's third law. When an object exerts a force on another object, the other object simultaneously will exert an oppositely directed force of equal magnitude on the first object. So object A and object B, they will basically exert the same forces on each other, but just in the opposite direction. Okay. 4.3. Draw a free body diagram. Remember, free is the dot, force is the block, indicating all the forces on the tow truck. So they want a free body diagram, so they want a dot for the tow truck. So for the tow truck, we can see we have weight, pulling it down. Then we have the applied force of 900 newtons of the engine. Then we also have normal force, which is equal to the weight. And then we have tension, remember, from that inelastic tow bar. And then we also have friction. That is a little bit shorter than tension. So you will get 5 marks because there's 5 forces. 4.4. If the coefficient of kinetic friction between the tow truck tires and the road is 0.4, calculate the magnitude of the tension. Okay, so we look at the tow truck, right? 4.4.1. We're going to use F net equals to MA or MA. So we look at the tow truck. We got to look at all the horizontal forces acting on it. So it's F net horizontal. So it will be the force of the engine minus the friction minus the tension, and that will equals to MA. All right. The force of the engine has been given as 900 newtons. Our friction, we have the kinetic friction. So we can use our formula. I'll just show you guys. We can use this formula to get that. So we can just say 0.45 is the mass times the gravitational force minus tension. Mass times 0. So anything times 0 is 0. So that stays 0. And then you do your bit of math calculations there and you get 3,267 newtons. 4.4.2. The coefficient of the kinetic between the car and the road of the road surface. So calculate the coefficient between the car and the road surface. So again, we're going to use F net equals to MA. But now we're going to look at the forces of the car, the horizontal forces of the car. If you can see, we only have tension and friction acting on that car. So its own tension minus friction is equals to MA. So the tension we have already calculated of the tow bar is 3267. So the tension here will also be 3267. And we don't have friction yet. And the cars and the tow truck and the car is traveling at constant velocity. So acceleration will also be 0. So anything times 0 is 0. So therefore friction will be 3267 newtons. But what do they want? They want the coefficient. So we're going to use that formula again. We're just going to manipulate it to get it to our liking. So we're going to insert 3267. This is the unknown, the coefficient. And we have the normal force. We can calculate it because normal force is mg, right? And therefore 3267 is 950 times 9.8. So the coefficient is 0.35. No unit. Remember, the coefficient of kinetic friction has no unit. And that is your final answer. Okay. Suddenly, the tow bar between the car and the tow truck disconnects and the car comes loose. 4.5. Using a relevant law of motion, explain why the car continues moving forward for a short distance, and that is thanks to Newton's first law. According to Newton's first law, and you have to obviously explain Newton's first law, so just give the definition, an object will continue moving at a constant velocity unless a non-zero net force acts on it. The net force acting on the car is the frictional force and causes the car to slow down. 4.6. Calculate the acceleration of the car as it comes to a stop after a short distance. So we use our trusted formula again, F net equals to ma. So now there's no tension, so it's only the friction, right? So it will be friction equals to ma. And we've already calculated the friction, which is going to be negative 3267. Remember, it's going in the opposite direction. And our mass is 950 and our acceleration is unknown. So therefore you do your little maths calculation there and get, you divide by 950 and you get negative 3,44 meters per second squared. And you can say either leave it at that or change it to positive and just write backwards or to the right. All right, easy, right? Okay, that's it, guys. See ya.